So today's class, we're going to go back and spend a bit of time setting you up with a Python execution environment, which it should work. I apologize for the beginning, that whole glitch with the word hall stuff. So if you could go, someone's there we go. Ricky's working on it. If you could go ahead and through Software Center install Anaconda. You should see it pop up when you type in Python or something like that. Run that if you haven't already. And to make sure that it's working from the command line, see if you can type Anaconda space prompt. And if you can get that far, we'll be set. Also, of course, download PyCharm. And I think most of you have done that already. All right. Anybody not able to find the Anaconda Software Center item or other issues? Riki, yeah.
I haven't been able to find it.
In Software Center?
Sorry?
In Software Center?
No, no, not in the Software Center. I didn't.
Huh. Okay. Are the rest of you able to find it in Software Center?
I just found it for the first time. If you type in Anaconda in the internet in the search USNA, there should be a blue link that says installing Python, and then that'll take you there. There's like links and stuff.
All right, great. They don't make it easy on you.
You said installing Python?
I can email you the link if you want.
Yeah, maybe can you put in the class chat just in case anybody else wants to use that? Awesome.
That's still like a PowerPoint for installing PDF.
Any other issues? All right. Anybody already have it installed? Like you can type Anaconda prompt and you see it come up. Okay. Good. All right. If you can, just keep working on that if you haven't got it squared away. I'm going to go through a set of slides here, and then we'll drop back into actually using Anaconda. But I want to show you what it is, and why we're need to install it first. So let me switch over here to slide mode. Okay, can you see the full slide deck? Greg, what do you think? Does it? You can see the whole thing?
Sure.
All right. Okay, so I was putting these slides together this morning, and I didn't get a great graphic here, but we've talked a lot about the difference between compiled code and interpreted code, and one of the big benefits of interpreted code is that it's portable. That if I'm working on a Mac and you're working on a Windows machine and someone else is working on a Linux box, we can all run the same Python code, which is very different than C. So given that the code can be used in different environments, all of a sudden, we have this possibility of reusing code. So if I am particularly good at writing a game engine, and Greg is really good at writing a code to talk to a serial port, why should I, have to do all this from scratch if myself and Greg are willing to share our code? So rather than everyone starting everything from scratch, let's have a central repository where anybody can publish their latest and greatest code, and if you like what you see, you can grab it and use it yourself, right? So that's the idea, and it's always this kind of fantasy vision that coders have, that we'll be able to efficiently reuse code and not have to start everything from scratch. Okay, and that's a big benefit of Python over other programming languages. So it turns out there is a central repository, and it's called PyPy. You can Just search for PYPI in Google and you'll see it. And it's this great website where you can just type in the name of a project and get some information about it. And if you like what you see, you can download it and use it yourself. So it's like an app store for code. But maybe even better, right? Because everything is free. There's no like, 99 cents to buy a module or something. Now the flip side perhaps is that anybody can publish a package. So just because you see something that purports to talk to Serial or to do something clever doesn't necessarily mean it works. There's no vetting of the code by anybody. If you are interested in uploading your own code to this repository, you can figure out how to do that on your own. I'm not going to talk about it in class, but it's very straightforward. We're going to be consumers of the code rather than contributors. So the way you interact with this app store is through a command line tool called pip, and that's the Python package interface. So pip has several commands. The ones we'll use most often are pip install, and then you simply put the name of the library you want to use. And these libraries are just Python scripts. They're just text files that have Python code in them. Okay, so you see on the right here, I've said pip install Pygame, and because I found Pygame on the PyPy site, and there it goes, successfully installed Pygame 1.9.6. You see that? And that number matches the number on the web page. Now, you might install many packages as you build up your project. If you start finding yourself wanting to do some machine vision stuff, you'll want to use something called OpenCV. Or if you want to work with hardware, you might want to use a serial interface called PySerial. So you'll find lots of libraries on this Python package index. And as you Google around and search for ways to solve your problem, you'll oftentimes find that somebody else has done it for you. Just pip install their thing. So you'll start to get a lot of libraries installed on your system. And you can see everything you've installed with pip list. And it shows you not only the name of the package, but also its version. And we're going to talk more about that version number in a little bit. And if you want to uninstall something, you just say pip uninstall that name. Does this make sense?
Yes, sir.
Okay. So I think it's a pretty straightforward vision. Right, that if you get some code that works, you share it on this site, and somebody else can use it. It's pretty straightforward. But it turns out that sharing code is hard. So just to make a concrete example, suppose I am going to create a game engine and share it with the world. I'm going to call my game engine my game. That's up to me to decide, and I publish it out, and it gives you a lot of functions that you can use in your own code. For example, something set pixel. And so the way we work with computer screens is that they are like a set of graph paper, right, with an X, Y axis. And so to set a particular dot on your screen, you would have to specify the horizontal, that would be the X, as well as the vertical, and that would be the Y. And the way we deal with color is by mixing different amounts of red, blue, and green. And it's just a quirk of human biology that you can mimic any color just using different intensities of these three primary colors. So this is fine. I make my library. This allows you to paint to the screen. Fine. And so you pip install my game. You write this great battleship game using this function set pixel, and you want to share it with the world. Send it to your friends. So you send them your Python script like game.py. And you say, hey, just say pip install my game before you run it, and that way you'll get the libraries. Okay. And that's pretty typical with Python code. But later on, I have some time on my hands, and I want to make an update to my library, right? You're not involved. This is my library. I'm going to update it, and I'm going to change how set pixel works. I think this is an improvement. So in the second iteration, not only can you specify the color of the pixel, but you can also specify the transparency of that pixel. So maybe if the screen is currently green, you can specify a new pixel that is slightly transparent, and that new color will be overlaid against the background green. And this will allow me to get some nice transparency going with my graphics. So all the people that follow my Twitch channel or whatever say, oh, this is great. Set pixel now has this great new capability. But you have a problem because you use my old version of the code where setPixel only required 5 parameters. You see that? And the new one requires 6. So if someone installs your cool Battleship game and says pip install my game, they'll get the new version of the code and it will totally break. Because they've got an extra, they're calling setPixel with only 5 parameters, and the thing they pip installed is the new one, and it has an extra alpha channel, right? It would be trivial for you to change your code to make it work with this new library. You could just set alpha equal to 0 so it's not transparent, and that's fine. And if you're actively maintaining your code, that's what you should do. You should get the latest version of the libraries, make sure your code works, and that's how things are kept up to date. But inevitably, you're going to lose interest in your Battleship game, and you're not going to maintain it anymore. And it'll be a real, crime, or, be a little bit sad, I suppose, if no one could play Battleship because of this dependency problem, right? That the My Game library no longer works with it. Okay, so when the difference between the top function and the bottom function is that somebody updated the library, and when they updated it, essentially the version of that library changed. So you need to, in addition to the actual code that you write, if you use libraries with your code, which you will, you need to also document the specific version of the libraries that you used. And so that when somebody else wants to run your code, they can install the particular version, and maybe that's not the latest one, maybe that's one that's a little bit older. And by documenting the versions, we can still use this shared code repository efficiently. What do we think? I don't see any faces. So
Makes sense, sir.
Does it make sense? Okay, Ricky says it makes sense. Marco, what do you think?
It sounds good, sir. I was trying to, do pip install whatever. Are there other steps we need to take in order for that to work?
Yes.
Oh, okay.
So this is still the great vision. We're just talking here. We'll get to brass tacks in a minute.
Okay, sounds good, sir.
Good. Because it's still harder. Sharing code is hard. There's another slide. The next slide is sharing code is even harder than you thought, right? So these are just problems that the naive developer would run into the first time they set up a shared code repository. They would, a month later, would realize, God, I didn't think of that problem, right? So these aren't the solutions of the problem. These are just the things you're gonna face, right? How do you control manage versions? Can we go forward? It's even harder than you thought, right? But still, it's nothing crazy, right? I mean, this is all imaginable. This is not like calculus. Sharing code is hard, but not hard, too hard. Okay, so imagine this. It's a little bit, the just read through this and then I'll speak to it. Okay, so now you're writing Battleship. Okay, you're using my game. You pip installed it and everything's working well. And you look to your left and you say, Marco, have you ever used this My Game library? He goes, oh yeah, I made this great Frogger game. It's so cool, and I recommend you try it. So you grab his code, his Frogger code. Okay, but lo and behold, it was written 5 years ago using a version of My Game that is different than yours. So you've pip installed My Game, but you pip installed the current version, and you're using the current version, and you need that version because you're using that alpha pixel, or that alpha setting. But he didn't. So you could go through your friend's code and change it and fix it all, and again, if you want to keep it all up to date and current, and that's what you would do. But let's be honest, you just want to play Frogger. You really don't want to have to go through and change every instance of setPixel to the new calling convention. So what we really need is for each one of these games to use its own version of the library. Right? Remember, I'm going to document all the versions that I'm using as part of my code base. And my friend should have done the same. And so wouldn't it be nice if there was a way to install multiple versions of the library and have each version associated with one program in particular? Okay, and this is going to be the final story, right? We need to have something called environments. So an environment is a way to isolate groups of libraries so that each program can use its own version. All right? And that way you can run Frogger, which is using an older version of the My Game library, as well as your new Battleship, which is using a different version, and there won't be any conflict. Okay, so just running pip by itself isn't quite the right answer. First, you want to say, let me create a sandbox, right? Let me create an environment. I'm going to give it a name, like battleship environment, and I'll put all my libraries into that thing. I'll put all my libraries into that box. And when I run battleship, I will specify, I'll tell Python to use that environment. And when I run Frogger, I'll use a different environment. I'll call that the Frogger environment. And that box will have a different version of all the libraries. Okay? So, how do we document the libraries we use? Well, it's very simple. You're going to create a file with the name requirements.txt. It's a text file, so it ends in .txt. Okay, and you're going to put every library you use in that file. And you're just going to say pygame, and then specify one of these kind of equality or inequality constraints and the version number. Okay, so I'm going to come back to this after we've played with pip a little bit and talk about version numbers and how do we do versioning. If you go back to here, notice that there's 3 numbers associated with a version. So 1.9.6. Of course, increasing versions means more recent, right? So 2.5.3 is certainly more recent than 1.9.6, but those numbers have a specific meaning, okay? And the meaning is something called semantic versioning. And it's a way for us to as a developer, you can use these version numbers to indicate to your users whether it's safe to upgrade the package. Okay, so if you're publishing my game, you want to tell your users, hey, will you need to change your own code if you pull down this update? Or was this update just some kind of improvement in the back end and you can use it safely? Okay, so 3 numbers here. The lowest number, right, the furthest right, the least significant digit, indicates a bug fix. So if you pushed out your library at 1.9.6 and it was fine, except it crashed when you called set pixel with a very large number, right? And people have huge monitors these days, so X might need to be quite large to get the pixel all the way to the far right. And so you realize this is a bug. You're like, oh god, what a mess! I forgot. Somehow my code is buggy there. I'm gonna fix it, and you should publish your version as 1.9.7, meaning that the code is not changed in any way. It just is less buggy than before. So you can always install something, upgrade a package where the only difference is the last number. Okay. So that's called a bug fix. Does it make sense?
Yes,
Yes, sir.
Okay. The next number is a feature release. So say you created a new function, like flip screen. Okay, this is a new feature, and you expect your users to just love this new aspect of the package. You didn't change anything else, so if it won't break anything. It's just a new feature, right? So a bug fix doesn't add anything; it just fixes what should have been fixed already. If you change the middle number, that means there's a new feature. So that's when you get excited. Like if you see the libraries you're using, all of a sudden it goes to 1.10.6. Like, ooh, I wonder what cool new feature the Pygame has. And you can look at the developer logs and find out that, oh yeah, they added a flip screen thing, and that's just what I need for my cool game. Okay, you can also safely upgrade a package when the middle number changes, because if you don't use the feature, fine, it doesn't hurt anybody. The most significant digit on the left here, right, the first digit is a major version, and that indicates a breaking change. That somehow the way you call set pixel is different than before. And you should not upgrade a package past a major version number. So if you are using 1.9.6, if you upgrade to 2 point something or other, expect to have to go change your code. Okay? And so that's what we can do at the end here in the semantic versioning. So you see breaking change, new feature, bug fix. And in your requirements file, you can specify Tilde equals is the nicest thing. It says, hey, make sure it's compatible, meaning make sure the first digit hasn't changed. The other digits, they could change, new features, bug fixes, fine. Double equals means you absolutely must match all three numbers, right? And greater than equals means, hey, it has to be a release, prior to 1.9.6, they didn't have what I needed. After that, upgrade as much as you want. Or, I don't recommend using this constraint, but you could say, hey, it turns out I'm not compatible with the new release. I'm requesting a version less than some specific number. Okay? And so with all this structure here, this ability to specify your requirements by version, the ability to isolate your libraries into environments, and the ability to access centrally hosted content is going to give us the ability to easily and efficiently share code. Okay? I think you were just seeing that in minimal version. I meant to show you that in full version, but so it goes. All right, so are you sufficiently motivated that this is why, because it's going to be a bit of a setup to get this wiring done. But the reason we're doing it is so that we can use someone else's code and stand on the shoulders of giants here. You could write the graphics driver from scratch for Battleship, but that would take you the rest of your time at the Naval Academy. And at the end of the day, maybe you'd get a red screen. It would be much more satisfying to use an existing library to get the graphics, and another library to do the hardware interface, and another one to do the networking, and put it all together, right? And that's more of the Python programming mindset than in C. It's like, I will do it all by myself, at the transistor level. And that's kind of the embedded mindset. Okay? Questions?
Sorry, I just got a quick question. So
Yeah.
the version thing, would that be, so in the scenario you're talking about where you're trying to make a Battleship game, would the Battleship game have the version 1.9.6, or would, as the writer of the Battleship game, you have to pay attention to what kind of sub programs you're using, and pay attention to which version those are?
Yes, that second part, right? Yeah. You don't need to version your own code. We'll talk about that next. When you want to share your code with another developer, when two of you are working on Battleship, then you need to version it yourself, right? And that's when we'll use version control software called Get. But for now, you as a developer are using someone else's version code. And so you need to pay attention to the version of Pygame or Serial or whatever. Okay? I think this will make more sense once we're back at the command line and you're typing this stuff. But, it's a chicken or the egg thing. If all you're doing is typing commands without understanding the why, that's hard to, grab. And if all you're doing is looking at slides, it gets a bit fuzzy as well. So let's try to do both here. And let's start the Anaconda prompt. Okay, so I'm going to switch over here and say C command. All right, do you see this? All right, so ignore that. Okay, so you should get a prompt something like this. If you type Anaconda prompt from the Windows search bar, hopefully drop into something like this. Give me a thumbs up when you're at the Anaconda prompt. Most of us are there. Paul's coming in. Okay. All right, so now the first thing I want to do is specify what sandbox I'm going to use. I need to specify my environment. Conda out of the box is going to give you one environment, and it's called base. And so we can say Conda activate base. And then we'll get a parentheses in front of our prompt saying that right now the environment is set to base. Okay? If you just type Conda by itself, you get a list of all of the things that you can do, right? Conda commands, so there's a lot we can do here. We're not going to do that much with Conda, but all the help is here, okay? Okay, so here I've shown a conda env list. If you run this command, you probably won't see anything except base. Do you see, is that right? I've got a few extras. And notice that I have an asterisk on base, meaning that is currently activated. Everything I type now will be using the libraries and stuff associated and installed into this environment. If I want to get out of this, kind of deactivate, now I'm no longer in a particular environment, and I say conda env list. Oh, that's my default one. Well, don't worry about it. Let's say, so anyway, conda activate base and get back in there. And CLS clears the screen. You don't have to worry about that. Okay, so now I want to say pip. Okay, and I can say pip list. Show me all the libraries. Look at this. I might have more than you. I'm surprised that there are this many. Do you have a lot or not that many?
There's a pretty good number of them.
Okay. There's many more than you're going to use in your code. Okay? Wow, so much. Okay? If you want to get this in a format for the requirements.txt, so now we start writing some Python code. We say Python, we say print, hello world, and it runs, and I'm convinced it runs, and all of a sudden I start writing fancier code, and I write a file that calls a bunch of functions, and then I realize to share this with you, to share this with Maria, I better tell her the version of all my libraries so that she can create an environment that matches my environment. Okay, because I'm not sure what she's working with. I don't know what weird library she has installed. I say create a new environment and install these packages. How do I send her the list of packages? I can say pip freeze. And that produces a output that you could just paste into requirements.txt. And this is the specific version of all of these things. Fine. Some of them are using this add file syntax. This is a disaster, right? If I said, hey, to run my simple code, you have to install 400 libraries, some of which are very particular, like this WC width has to be this particular build. Okay? And she's like, wow, that seems like a major hassle. I bet your code is awesome, but I will stick to my own stuff. So it's best if we create, for a new project, it's much better if we create a new environment. We don't use this base thing. What if we create an empty, pristine sandbox, and as we come across a dependency we need, we add just that dependency. We say, just Pygame, right? And that way, even though we might have a bunch of libraries in our system, and some of them might just be in there because Windows is cool, right? We don't actually need them for this project. So the best, practice is for a new project like Battleship, right, to start with a new environment. Don't use any other packages. It's pristine, and as you add dependencies, as you pip install them, you'll just get a nice shorter list of items, right? So we can say conda env, and then I think it's create. Let's see. Yeah, let's not. And you can do all this environment creation from the command line, but it's much easier to let PyCharm handle it for us. Okay.
So if we just have 3 carrots facing to the right, how do we get back to where it says base?
Oh, you can type, so that, like Python, that means you're in the interpreter here, right?
Yes, sir.
Then you can type quit parentheses. That's a function that quits it, or you can hit Control Z and then enter. Yeah, good question. Good question. Okay, so our goal is to use PyCharm to handle this environment stuff for us, right? In some way, right? So let's go ahead and start up PyCharm now, and we're going to create a new project. So I'll share my screen here, and Oh, there I'm doing set pixel and silly stuff like that. Let me say file. If you don't have a project open, you'll see just new project. If you do have your old file open, just say new project at the top here. Okay. And then it's going to be a pure Python project at the top. And then set the location to like what we discussed. Something, you know, a folder on your desktop, a folder in your documents, something like that, right? And then give it a name. And I'll call it class demo. It doesn't matter. Okay. And then we're going to create a new environment. You see that selector? And we're going to select of the different, there's different ways to create Python environments. And the out of the box one, if you just downloaded Python from python.org, would be something called virtual env. But Conda is another way of managing your environments, and we'll select that because that's what Software Center gives you. So you're all able to select Conda here? Okay. Notice that the location of your environment is going to be in this ems. So users, Donald, right? Yours is going to be something else. And then it's going to place all of your libraries, everything you install, is going to be located in this class demo sandbox. Okay, and then we can specify the Python version. So this is, you know, even cooler, right? Not only can we control the particular version of Pygame we're using, we can also control the particular version of Python, the interpreter that we're using. Because, you know, Python continues to get upgraded, and sometimes there's a breaking change. The change from 2 to 3 introduced a lot of headaches. And if you had code that worked in Python 2 and you weren't interested in the features in 3, why do you have to upgrade to 3? Why can't you just keep running what used to work? And so by using these environments, you could specify that, hey, I insist on using Python 2.7. It's not great. There's all kinds of problems with 2.7, but you can. We're going to use 3.7. So 3.8 is the latest and greatest. We're going to use 3.7 because Pygame doesn't support 3.8 yet. Okay? And then uncheck create a main.py welcome script. It just has a lot more Python syntax and tools than we've discussed so far, so I don't want to go through that line by line. I'd rather start from scratch. Okay? So click create. And if you already had a project open, go ahead and save this window and it will close out that other project and open up your new one. And notice you get that dialog, creating a Conda environment. It's building that infrastructure, that sandbox for you. Okay. All right, and so now when I go back to my Conda tab here, I can say Conda env list. And now you see class demo, right? So I can say conda env activate, switch over to my new class demo environment. Oh, what did I do here? Oh, sorry, conda activate. Okay, and then you see the parentheses changes from base to class demo. And if I say pip show, or pip list, sorry, there's just a few in here. This is much more reasonable. And if I say pip freeze, the only thing I would need to put into my requirements.txt are these two lines. Okay, so this is a clean, nice environment. A little empty sandbox. And I'm not requiring many dependencies at all. These are just the fundamental ones to kind of start up a Python project. Give me a thumbs up if we're still there. Okay. It's so clean that there's actually no Python code, right? we haven't actually written anything yet. So let's go ahead and we can say start an interactive session in our sandbox, right? And we've done this several times. Notice that the version of Python is 3.7 as we requested. If you don't see 3.7 there, you did something wrong. Let me know. We can destroy this environment and create a new one. But you should see 3.7. And we can do all this fun stuff. Print hello world. You can get tired of typing this, right? But we talked last time that if you don't want to type everything line by line in the interactive shell here, why not create a text file with all your code? Okay? So let's open up Windows Explorer, and I really want to continue to emphasize this fact. PyCharm puts a lot together. It's a very clever interface, and it looks kind of magical, and it's just helping us out. I want you to understand how to do everything on your own, and so PyCharm looks less magical. So go ahead and find your code using Windows Explorer. So open up a Windows Explorer here. Go to wherever you saved your code. Open up Python. Open up class demo. Okay. And the only thing in there should be a .idea folder. It's empty. There's nothing here. Right? The .idea folder is all your preferences for PyCharm. So if you said, I want dark mode, or I want light mode, or I want my font size to be 32 pixels or something, all that's stored in the .idea folder. The dot indicates it should be hidden and ignored by the average user. Okay? Let's go ahead and create a new file, and we'll do just like we did in the first week. We'll create a text document. Okay? I'm going to call it main. And I'm going to say print hello world again. I'm going to save it. Okay. And look what just showed up in PyCharm. Main.txt. Yeah? So this is just showing you the contents of this directory. Okay? And there's nothing magical to file extensions. They're just hints that the computer uses to know how to run your, thing. Whether it's a .doc, it should open up Microsoft Word first, and Microsoft Word knows how to read that file. Or .text is just flat text, right? .py, it means it's a flat text file, but it should be treated like Python code. So let's run it. We say quit on our Anaconda thing here. And then remember, I can just, I've got to specify the full path to my script. It's not in users Donna, it's in my class demo thing. So you can just drag the name of the file. So, let me show you that. Right here, you can click main and just drag it onto the Anaconda prompt. And it will populate the full path to that file. If you have spaces in your name, like if your name has got a space in it or there's something else, you'll have to put double quotes around this whole thing. But notice that I can execute, right, main.txt. The .py means nothing. Can you all execute main.txt? Anybody cannot execute it. Right? Yeah, Kyle, yeah.
Sure, I can see it. It comes up, but there's no run. If that should happen. Is that what you mean?
So in my command here, you see if I hit the up arrow. Oh, can I do the up arrow here? Let's see.
Oh, you mean in command prompt.
And then you hit enter. It should run.
So you just did Python and then the link to it, or
the full path, right? It's saying, hey, where is that text file you want me to run? Right? If you're more familiar with the command prompt, you can actually change your working directory to point to move into that. Right? And now you see my path has changed, right? And so if I say dir, you see that main.txt is right here, and then you say Python main.txt. But I'm not going to expect you to navigate through the command line like a wizard. I just want you to know what's going on behind the scenes. Because wouldn't it be nicer if I didn't have to open up this Anaconda prompt, if I could just hit the play button from PyCharm and have it run? Okay? So, one of the biggest things with a development environment that we're gonna really enjoy is the ability for it to detect syntax errors, highlight the code, based on whether it's a comment or a function call or a string, and to do that, PyCharm is going to require us to have the right suffix, the right extension to our file. So let's change main.txt to main.py. All right, so if we right click on this and say refactor rename, we can just change the .txt to a .py. Okay, and now all of a sudden you see there's a little icon on the, or an inset on the icon here that indicates that file is recognized as Python. And lo and behold, the string is highlighted green, and I've got the built-in function print highlighted purple. Okay, so that's what the extension is going to give us. It's nothing magical. It just lets PyCharm know, hey, this is Python Go, let's change the coloring. All right? So we're almost there. We just need to tell PyCharm, okay, what it means to run this project. Right now it's pretty clear. We have one Python file, but pretty soon you're going to have 15 Python files. Which one has the int main in it, right? Which ones should start your program? So to do this, we're going to click Add Configuration at the top. We don't have any existing configurations. We're going to hit plus. Okay. And then we're going to scroll down to Python. All right. And you can give it a name like default or something, right? And then we have to tell it what is the name of our, text file we want to run. Okay. And then not only that, we have to tell it what is the environment, the sandbox we want to use. I have class demo here, Python Project 1, Hello World. Those are a couple other ones I had made in, my experimentation. But you should only have the class demo there. Okay? So once you do this, you click OK. And then if you get this Windows Defender thing, we can go ahead and say do this automatically. That's fine. And now when I click play, finally, hello world. Okay? And so at this point, we have we really worked hard here, and we're only scratching the surface of what we've just built, right? We haven't really used libraries yet, and our program is pretty simple to run. Right, but this is a great platform that now we can start to really write some Python code here and watch it run and debug it and pause the execution and stuff like this. Okay? So my goal, and I'll take your feedback on it. You can send me an email. I'll also pull the class at the beginning of next in the lab tomorrow. But I try to provide you with the things that are harder to get, online, right? So you can find out how to program Python from 1,000 different tutorials. I think the textbook that I pointed you at is good, and I meant to send you an email with a couple other textbooks. I'll do that right after this class. A lot harder is sort of the reasoning behind these environments and setting up your toolkits and stuff like this. So my goal with the lectures is to provide you some insight that you wouldn't get if you just decided on a Thursday you want to learn Python, right? If you'd like me to really just focus on the semantics of the language and say, how do you do a for loop? And let's do 5 for loops today. Sort of like what we did in 200. We can do that as well. But sometimes the students say, oh, God, that was, I still have nightmares about those 100 deck slideshows. And I'd rather just, peruse through a couple tutorials and get a feel for the language. Don't answer me now. Think about it, right? And we can structure the class to meet your needs. Okay? I think that's about it. Any questions? Now the only thing I will tell you I must know now is if you are not able to click play and run this thing. I want to put this all to bed here and say everyone's got a working Python environment. So don't just say I saw you do it, Dr. Don. I'm pretty sure I can do it on my own. Right? That won't work. I want you to right now.
Everything working except that idle thing, because I can't download that.
Oh, idle! Don't do it. Right. So the book talks about idle. That's a lighter, cheaper version of PyCharm. We're going to be using PyCharm instead of idle. Yeah.
Sir, I never got past the conda command was never recognized by my command prompt, so I.
Oh no! All right. Well, in the future, please interrupt me right away. Make sure you're in the Anaconda prompt and not in the command prompt. So don't type CMD. You've got to be in the Anaconda prompt. So from the Windows search bar down there, type in Anaconda prompt, and you should get something that looks very similar to the command prompt, but it's actually different. And then the conda command should be recognized there.
It's not, sir.
All right. Well, okay. Why don't we? Anybody else have issues? Okay. Then go ahead. You can head out. I will see you tomorrow for lab. And in the meantime, continue to work through Python. Please bring your questions tomorrow about the language itself. Say, hey, for loops don't make any sense, or can you talk about functions? And we'll start our class that way. Let's see, Marco, just stick around for a minute, and we'll get you squared away. If you could share your screen, I can kind of step you through it.
Yes, sir.
All right. See you all tomorrow.
Sir, should we download Pygame, or do we have to download that?
We will do that when we start doing Pygame. So we'll say pip install Pygame, and you can do it now if you want. You won't. Later on in the book, if you go to much further chapters in the book, they use Pygame, but we'll be using pip to handle that, and we'll talk about that once we finish the introduction to the language.
Okay, thank you.
Great.
Sir, I got a question too, but I kind of want to stick around and get the review.
Okay, sure. So, Marco, why don't you share your screen there?
Yes, sir. Sir, it says the host disabled participant screen sharing.
Gosh, let's see. Okay, go ahead.
I got my Anaconda prompt up.
Activate.bat. Did you do more ahead of that, or that first line popped up for you automatically that activate.bat is not recognized?
I will see. Yeah.
Okay, so that indicates to me that thing somehow didn't install correctly. From the command prompt or from the Windows search bar, can you type Anaconda Navigator? Yeah, open that up. Okay. Go ahead and launch that first one, command.exe prompt. Okay, there you go. Type conda. Just this word conda. Okay. So, yeah, for some reason the shortcut to get into this command prompt doesn't work, but this is fine. So if you say conda env list, E and V.
Oh.
Great. So you've got the base and this thing Python project, which is what you might have just started, right, with PyCharm. If you say conda env activate, and then you got to tell what to activate. So conda env activate Python project, right? Because right now you see at the left of your prompt it says base. We want to go into the Python project. Conda activate. I'm always messing that up. Conda activate Python project. And this will switch sandboxes. So now on the left, you see in the parentheses is Python project. So now if you say pip show, or pip list, you should just see a few packages. Not that crazy screen from the base. If you say pip activate base, and you'll go to the base sandbox, that has a bunch of crazy stuff in it. And that's, polluting your sandbox. We want our sandbox to be as empty as possible.
So the Python project is kind of specific to Python package-wise?
Python project is what you just created when you opened up PyCharm. When you said, I want to create a new project, the default name for a new project in Python is called Python project, right? We'll create, when you start working on Battleship, for example, you'll create a new virtual environment. Maybe we'll call that Battleship. Right, but these are all little sandboxes, little containers that will hold our code and keep it separate. The library is separate from others.
Right. I never explicitly created anything called Python project, though, so I'm not really sure where.
Well, so you're opening up PyCharm right now, right?
Yes, sir.
All right, so let's wait until that loads. All right, Greg, did you have any particular questions? You see, you already created that, right? Python project. You must have done that previously. So, click X there. Fine. Remove from list. X. Oh, yeah. I'll close that out, yeah. Say new project. Right? Pure Python. And you see in that top location there?
Yes.
That's the name. So, you can change that. Change that to something else, like class demo.
Demo. Oh, there we go.
Open up that triangle, right? And we're going to use the environment. We're going to call it conda. And you see the name of that environment is going to be called this very long thing, 26 Aug26 underscore anaconda underscore class demo. You see that?
Yes, sir.
Under new environment using conda?
Yes, sir.
Okay. Change the Python version to 3.7. Yeah. And then click create. All right, and if you go back, see it says creating conda environment. If you go back to that command prompt and you say conda env list, you should see your new environment pop up. Maybe do it again. Or, PyCharm is creating as we speak. All right, great. You see that crazy long name there?
Yes, sir.
Okay, so that is going to be your sandbox, and it's pristine. It's a brand new, fresh sandbox. Okay, and that's going to be where you install any libraries that you want to use with the project you just created right now. If you don't install any libraries, then these sandboxes are pretty useless. But we will quickly start installing libraries. So now, in this very empty thing, we talked about adding a text file manually using Windows Explorer, but here you can just right-click on this and say New Python file. Say New. What are you doing there? Data source. All right, get out of here. I think you clicked on.
I make it.
All right, right-click on the name of that folder there. New Python file. New Python file, and then name it like Marco.py, main.py. The name of it doesn't matter in the least. But by convention, we'll call them main.py. And then just type something fun in there, like x equals 2 or print hello world or, something. If you type print, then it's nice because you can actually see that it ran. All right, cool. Howdy. Perfect. Okay. You can go back now to your conda prompt there. Okay. And if you type Python space and then that path to your file, you could run that file. Now that location you saved it to is quite the location. It's not, that's the end. That's where the sandbox lives. The actual code that you're writing, you'd have to go to Windows Explorer and get that path, right? You saved it, I don't know, in your desktop off of something.
So, like, I know where it is.
Okay, yeah, just find it somewhere. There, you see main.py. So just drag that
Okay.
over onto the, and that just is a shortcut for actually typing that long thing. See that?
Sir.
All right, so go back and put a space. Unfortunately, the cursor doesn't work in the command prompt, so you actually got to hit the back arrow. No, not the up arrow, the left arrow. Or just say Python space and then it's still on your clipboard. So.
Oh yeah, it is.
Right, and then slash main.py. Oh wait, that the other slash, but then you're in your M's directory here. So this must be a different. Yeah, this is different. So you backspace that out and where are you at there? Yeah, okay.
So first I will backspace out of this.
Yeah.
Leave a space.
There you go. There you go.
So,
Double click that and then drag main.py. Just the icon, yeah. Right, and you could have typed that yourself. That's the location of the file in your file system, but who wants to type all that? Hit enter. Howdy, right? Now, doing this is tedious, right? I think it's important that you understand that that's how it's working, right? It's calling the Python interpreter and running your script. It's nicer to do it all through PyCharm and just hit the green arrow in PyCharm, right? So go back to PyCharm and say add configuration at the top there. Plus.
Python.
Yep. And then we're going to have to tell it that we want to use the main.py. So open up that folder, main.py. You see it's already set up for your sandbox, right? Everything's good. Click OK. And now this is as if you had opened up that prompt and done all that. Click the green arrow there at the top. Howdy, right?
Okay.
And then you could change that to like howdy folks or something. And if you play again, it would say howdy folks.
Yes, sir. So what exactly is the point of going? Like what is Anaconda? Like I understand what we were doing with like the Python, and I understood what we were doing with like this wasn't Anaconda, but I'm not sure why Anaconda is different or what is.
So it's basically levels of layer cake here, right? Like all you really need to write Python is a text editor and the Python program itself, right? So that's what I tried to show you that first day of class, and everyone's like, "Oh my God, Ward Hall has locked down our computers, so we can't actually, do it this way." I think the CS department must use Python, and they use Anaconda. Anaconda is this massive setup which allows you to use Python in all these different ways and maybe different versions of it, and maybe you want to use R, which is a statistics package. It's more than I want to talk about. It's supposed to be helpful, but for someone new to the language and just trying to learn Python, it's a lot of like, why did I just, we're gonna ignore pretty much all of Anaconda. We're just gonna be done with it and let it run in the background. It allows you to have several versions of the Python interpreter running at the same time. So in the same way that I said you have this problem that you might have a version of my game and I have a different version and you want to have these sandboxes, you might have a bigger problem. Part of your code runs in Python 2.7 and part of your code runs in Python 3.8. Right? And wouldn't it be great if you could run both of these at the same time as MATLAB and have them all talk to each other in this amazing, passing of data back and forth, and that's Anaconda. Right, that's out in the clouds. We don't need to do all that.
Create multiple sandboxes that are running on different versions.
Right.
But it can still pass information among those sandboxes.
Pretty much, yeah. Which is, I guess, something the CS department needs to do, but we don't, fortunately. So we're gonna keep it a little simpler.
Okay.
All right, so hang in there. I think this will all come together. I'm sure it's a bit of a soup. But once we start writing programs, I think you'll start to get more comfortable with it.
I think if we get into like a battle rhythm of how we're doing it, it might
Yeah.
make more sense.
Yeah. This should be the last day of wiring it up, right? Once it's all done, we'll basically use the green arrow to play our Python code and not really worry about how it's running.
Sounds good to me, sir.
All right, very good. Greg, did that answer some questions, or you got some other things going on?
Yes, sir. Actually, I was hanging in there for almost the entire thing. I just kind of got lost when it got to the add configuration part, so then we can get it into PyCharm.
Okay, yeah, why don't you go and share your screen?
All right. Okay, that's oh yeah, here we go. Can you see like all four of them? Sir?
I can see all four.
Okay, so then we go, this is the main.txt.
Okay.
This is Anaconda. This
Yep.
is like the class demo.
Yep, good. I like it all.
And then
Yeah.
this is PyCharm, obviously. So.
Great.
And then go to add configuration.
All right, so click at the plus in the top there, yeah, Python.
Go all the way down. Right there, this one?
Mm-hmm.
Okay.
And then you're going to want to set the script path. You click that folder browser. And then open up class demo. Oh, there you go. And wherever what are you in demo? What's your folder where you've got main.py? What's that path?
Main.py. I only have main.txt.
Oh, okay. So first, go ahead for this browser thing to find your script. It's going to filter it, so you only see .py files. So go ahead and it's a little harder. Windows Explorer makes it very difficult for you to change the extension of a file. It's much easier to do it, although it looks like you already exposed it. However you want to change it, it just ended in main.py.
Oh, I opened another one. My computer's being really slow too. Here we go. It's gonna take forever. Yep, look at that.
Yeah, it's not happy with you right there, huh? Okay. Well, you can just leave that alone. Yeah, close. Yeah, whatever. Go back to PyCharm. You can do this all from PyCharm. Just right-click on the main.txt file. Oh, or
Click on the main.txt file.
no. Yeah, right-click. Let's just right-click on that and say refactor. That means like change something about this. And then rename is the thing you want to do to it, and just change it to Py. All right.
Okay.
And now when you click the plus and go to Python, you should see that it shows up as something that it recognizes as Python code. So open up class demo.
There we go.
Yeah. Right? And so that's just filling that text. I mean, you could have written that text yourself, and you could say, I insist on all my Python files ending in .txt. And so you could backspace py and put txt, but then you're just fighting upriver for no reason, right? So you just go with .py and life is easy. You see that you've got the Python interpreter set up to your sandbox. Everything's good here. Click OK. And then you should be able to click Run.
There's nothing like here, though.
Well, sure. You can double click on main.py to open it up.
Oh, okay.
Yeah. But unlike, maybe you're familiar with embed or something, we don't, since we've set up the script and said what the green button means, you could be in a different Python file, still hit the green button, and we'll run main.py. Right? So as you build out more complicated programs, you might be deep in some other set of Python files, and when you click play, it'll play your whole game, and not just that one particular file you're editing.
Okay.
All right?
That makes sense. Okay.
Yeah, I mean, I wish we could introduce the layers to the cake as you needed the new layer. Like, hey, we can't do this. Let's add a layer. Unfortunately, the way your computer is set up, we have to throw the whole layer cake at you, which is a lot of mess. And then only months from now will you realize how they all why you need the sandbox. But you do need it. We'll get there, and at the end of the course you'll go, oh yeah, it all makes sense. How clever. But for now, that's the only wiring. From now on, we'll just click the play button and won't worry about what's going on behind the scenes.
All right, sounds good, sir.
Okay.
Thank you.
Good. All right, well, I'll see you tomorrow.
See you tomorrow, sir.